Right. Hey guys, so this is going to be the lesson for Thursday. This should be. This is a continuation of what we talked about yesterday. We're still going to be talking about determining if an equation is linear, exponential, or quadratic. But today we're going to be talking about it in terms of their tables and not their graphs or their equations. So there's three ways really. I'm not sure why that's selected to represent an equation or a function. And first off, on the left, you got a graph. All these equations have graphs. Yesterday we talked about what the different graphs look like. We also talked about their equations, how they look differently. So these two portions we covered yesterday, graphs and equations. Today we're going to talk about tables of values. So this requires not a whole lot of work, but a little bit of work. And we have to make sure we follow the steps correctly. I think this is going to be okay. I think this will be another fairly painless lesson, I hope. Remember, if you have questions, please ask. Email me, post it in Google Classroom. I may set some things up for you guys to ask questions. If it ever gets to be a point where everyone has a question, either I'll redo a lesson, or if there's quite a few people have questions, maybe we'll Zoom conference. I'll definitely be in contact with you guys every day. And before we keep going on, make sure you fill out your Google form about attendance. That way I can mark that you were here today. Please make sure you're watching the videos and doing your homework in a timely manner, right? You would be doing it before 4 every day if you were in school, so maybe do the same. Because remember, after 4 I might not be available. Especially if it's late at night, I definitely won't be available. Mr. Bush is a tired guy. He needs his 8 hours of sleep, if not more. So let's go on to determining whether these are linear, exponential, or quadratic. So we're going to be given a table of values, just an XY table, and we have to figure out if it's linear, exponential, or quadratic. So we're not going to have an equation and we're not going to have a graph. We're just going to have a table of values, an XY table, and we have to figure it out. Okay? So let's start out with the easiest, and that is linear. Let me scroll down a little bit. Can I move this maybe? So linear, the first difference of y values are the same. So what we're going to do is I write down in all these problems my y values, but I start from the last given to the first given. Okay, this is important. So I'm going to write down my last y value, which is 1, and then the next one is 3, then the next one is 5, and the next one is 7. So in order for it to be linear, the difference between these have to be the same. So the difference between 1 and 3 has to be the same. The difference from 3 to 5 is the same. And the difference from 5 to 7 is the same. So let's see. You have to think, what do you add to 1 to get to 3? Or what do you subtract from 1 to get to 3? Hopefully this one's obvious. Plus 2, right? From 3 to 5, add 2. From 5 to 7, add 2. Well, guess what? This right here is called the first difference. So when I write that linear, when I wrote up above, the first difference of the y values are the same, that's what I mean. The first difference, the difference between their y values are the same, which it is. So if this happens, you get the same value, then it's linear. Okay? That's the easiest one. You only have to do the first difference. I mean, honestly, if you look at the XY table and look at the y values, you should see that you have to subtract every time, right? 7, 5, 3, 1. The difference is all 2. But I write out my y values. Now I write them from the last one given to the first one given. So again, important. We're doing our y values, not our x values. Y values, not x. Okay? So y values. And we write them in backwards order. So we start at 1 and we go back to 7. Okay? So that's for linear. Let's go on to quadratic, because this is the second easiest, I think. And so this time, the second difference is going to be the same. Okay? And so it's going to be the same steps. I'm going to write it out from the last y value given to the first y value given. So I'm going to write out -6, -4, 0, and 6. Okay? And so now I'm going to write out their first difference. So to get from -6 to -4, what do we have to add or subtract? It should be 2, right? To get from -4 to 0, you add 4. And from 0 to 6, you add 6. And that, what we did right there, is the first difference. So if I didn't tell you this was a quadratic, if I just gave you this table of values, right off the bat, we should know that this is not linear because these are different, right? 2 and 4 and 6 are different. However, now we have to do that same thing again with what we call our second difference. Okay? And so we're going to use our differences and see the difference between our differences, or the second difference. So, to get from a +2 to a +4, hopefully this one's obvious, you add 2. To get from +4 to a +6, you, again, add 2. Well, look, these are the same values, right? And so, in order for a table of values to be quadratic, the second difference has to be the same. Well, this right here is our second difference. Okay? And so we basically had to do what we did for linear twice, but it's not bad. It's not hard math at all. You just have to know the steps, okay? So it's important, again, that we're taking notes. But a quadratic, the second difference is the same. The first difference is not the same. If the first difference is the same, it's linear. If the second difference is the same, then it's quadratic. So just like yesterday, we talked about linear, quadratic, and exponential. So in exponential, it's neither of them are the same. Okay? Neither the first nor the second. So let's, again, do the same steps. We're going to start with our y's, the last one given to the first one given. So I'm going to start with 67, then 19, then 7, and then 4. So I challenge you to pause the video for a second and see if you can calculate the first difference. Okay? But I'm going to keep going, so unpause me when you're ready. So to get from 67 to 19, hopefully it's obvious that we subtract, right? You should subtract 48. Okay? Well, from 19 to 7, you subtract 12. From 7 to 4, you subtract 3. So, first difference. They're not the same, so they can't be linear. Okay? Well, let's calculate the second difference to see if it's quadratic. So what do we add to -48 to get -12? Okay? So you should add 36. Because if you're -48 and you add 36, that'll get you back to -12. Well, let's see what happens to this one. What do we add to -12 to get to -3? Well, that should be a +9. Is the second difference the same? No, it is not. So that means if neither are the same, then it's going to be exponential. Okay? So, to reiterate, first off, these sentences that I wrote, you should probably have them written down in your notes. If just the first difference is the same, it's linear. If the second difference is the same, it's quadratic. And if neither are the same, it's exponential. okay? And so what our homework problems are going to look like is it's going to give you an XY table, and we have to figure out if it is linear, quadratic, or exponential, okay? And so feel free to, when I show an example, pause the video and try it for yourself, and then see what I did, and see if we did the same thing or if we did something wrong, okay? So, as promised, determine whether the table of values represents a linear, exponential, or quadratic function, okay? And so we have our table of values, and so I'm going to do the same steps I've done with every problem. I'm going to start at the bottom. I'm going to start at the last y value and go back to the first. So I got 20, my shadow's in the way, I can't see. 12, 6, 2, and 0. Oh, don't write that 0 too close to that 2. Silly Mr. Blursh. Okay. So first difference. What do you add or subtract from 20 to get to 12? Well, hopefully that's obvious. You subtract 8. From 12 to 6, well, it gets smaller, so you have to subtract. So you subtract 6 again. From 6 to 2, you have to subtract 4. And from 2 to 0, you subtract 2. So that right there is our first difference. I'll abbreviate. First difference. Is our first difference the same? No, it's definitely not. So it's not linear, okay? It's not linear. So then we have to go on to the second difference. Well, to get from -8 to -6, you add 2, right? To get from -6 to -4, you add 2. And from -4 to -2, you add 2. Oh, look. The second differences are all the same, which means that the function is a quadratic. So this is, your answer would be quadratic. Okay? And so, maybe I shouldn't assume things, but this work that I showed, this should be shown on your work. Okay? I don't want to see just the answer quadratic. I want to see the actual work, okay? That needs to be a thing. I need to see your work. So, this is a quadratic because the first difference was different, but the second difference was the same. So let's go on to another one. Now they can write XY tables differently. Sometimes they do them horizontally like this, and it's the same thing. We're looking at our Y values, right? And this is our first Y value. This is our last one that they give us. And so we're still going to start with the last one they give us and go backwards, okay? So don't be thrown off by the fact that it looks a little different. So, if I scroll down a little bit, if you don't mind. The last Y value they give us is 21. Then it's 18. Then it's 15. Then it's 12. And then it's 9. Alright, so let's calculate the first difference. To go from 21 to 18, we subtract 3, right? To get from 18 to 15, you subtract 3. To go from 15 to 12, you subtract 3. And to go from 12 to 9, you subtract 3. Well, that's our first difference, right? And I'll abbreviate again. Well, if the first difference is the same, we know that the function has to be linear. So those are really easy. You just have to do one line of work. Sorry. So that table of values is linear, which means its graph would be a straight line, and its function would not have any exponents. Okay? Let's do another one. And again, same thing. They wrote out the table of values horizontally instead of vertically. You just have to look at first your Y values. We're not dealing with our X values, so you don't need to worry about that at all. We just want to look at the Y values. And then we want to go from the last one given, which is over here, and go backwards to the first one that was given. So, oh, too far. Last one that was given is 13.5. The next one is 4.5. Next one 1.5, and the last one is 0.5. So we need to find the common difference. So you might have to use your calculators to figure this out, but we need to figure out what you add or subtract from 13.5 to get 4.5, okay? So honestly, I would do 13.5 minus 4.5, and that gets you 9, which is the difference between these two. So if you think you have to subtract 9 from 13.5 to get 4.5, okay? And again, how much do we have to subtract from 4.5 to get to 1.5? Well, that's minus 3. And you get from 1.5 to 0.5, that's minus 1. So, first difference. Is it the same? Heck no. So let's calculate our second difference. Okay? So to get from negative 9 to negative 3, you add 6. And to get from negative 3 to negative 1, you add 2. And that's our second difference. Are those values the same? No, they're not, which means our equation has to be exponential. Okay, so basically, to sum it up, linear, first difference is same. Quadratic, second difference is same. Exponential, neither of the differences are the same. Okay? So this is exactly what your homework is going to look like. I'm just going to give you tables of values. They could be vertical tables, they could be horizontal tables. Either way, and I need you to show me the work of finding the first and second differences, and then your final answer is the type of equation. So either linear, quadratic, or exponential. And so again, just like yesterday, I'm going to post the homework in Google Classroom. You'll have to either print it out and do it on there, or do it on a separate piece of paper. And you need to show all your work. Take a picture of all of the questions. I would just do one picture, maybe two if you can't fit it all on one page, and upload it to the assignment. Again, I think this is going to be due tomorrow, Friday at noon. This could change. I'll let you guys know via Google Classroom. Again, make sure that we're working on this in a timely manner. If you have questions, please ask me, email me. If there's anything drastic, we can Zoom call, or I can work certain problems out on a video. Just let me know what I need to do to help you guys, okay? So with that, I will see you guys tomorrow.